Welcome to today's video of AP Psychology on the influence of drugs on neurotransmitters. So, as a quick review, we know that the brain is made up of cells called neurons, and these neurons communicate with each other, which allows for signals within our brain, and they also communicate with the rest of our bodies, which allows us to perceive the world around us and give signals from our brain to the various organs in our body. If we look closer, we can see that inside these neurons, the signals are being carried via electrical action potentials. However, as we move to the end of the neurons, or the axon terminal, this electric signal is going to get converted into a chemical signal by the release of neurotransmitters, which are just chemicals that are released by the neuron. So the area between neurons we call the synapse. And these neurotransmitters will get released and then spread in the synapse. And eventually, they'll just bind to another neuron. And this is the signal receiving end of the neuron, which we call the dendrite. Now, the neurotransmitter will bind to its respective receptor on the dendrite. So let's say if we're talking about the neurotransmitter dopamine, then that dopamine would bind to a dopamine receptor. And this would cause the signal to propagate into the neuron. Now, the signal could either be excitatory or inhibitory, all depending on what type of receptor it is. Finally, the neurotransmitters will get reabsorbed out of the synapse in a process we call reuptake. If reuptake was not present, then the neurotransmitters would continue to be in high levels of the synapse, and they'll continue to act on the receptors, and the signal would not stop. Now, this same synapse is also the location where a lot of drugs have their effects. If the signaling is out of balance, say either too little signal or too much signal, then we could use drugs to help bring it back into balance. On the other hand, drugs that are used inappropriately can throw our own natural signaling out of balance. This is AP Psychology, not advanced pharmacology. So for this video, we're just going to classify drugs that work on neurotransmitters into three main categories, these being agonists, antagonists, and reuptake inhibitors. So let's start with agonists. Agonists are chemicals that will bind the receptor of a neurotransmitter and cause the same effect as that neurotransmitter. Right? Easy. So an example of this is morphine, which is an agonist for the endorphin neurotransmitters. So normally, endorphins will bind to their own receptors and give us generally a happiness sensation. Now, morphine, which is a drug, will bind to the exact same receptor as the endorphins, and they'll cause the same effect on the neuron, which gives us the same kind of happiness sensation. This is why people who use morphine get a high, right? So those are agonists. On the other hand, we have antagonists. These are the opposite. They go against the effect of the neurotransmitter. So these two words sound very similar. So just remember, the ant in antagonist is like anti or against, right? Antagonist goes against, agonist goes with. So an example of an antagonist is atropine, which is an antagonist of the neurotransmitter acetylcholine, right? So normally acetylcholine will bind to its receptor, the acetylcholine receptor, and cause an excitatory signal. This is used in the body for movement, right? Like getting our muscles to move. However, if there is too much signaling of acetylcholine, then there tends to be a lot of muscle shaking or tremors, which is very common in Parkinson's disease. So in this case, if we have a patient with too much movement, we give them the drug atropine, and this is going to bind to that acetylcholine receptor. Once it binds, it's going to prevent the acetylcholine from binding, and it itself does not cause a signal. So in general, this will prevent the acetylcholine signal, and thus it goes against the effect of acetylcholine. Finally, we have the category of reuptake inhibitor. Remember now, in a normal synapse, after the signal is done, the neurotransmitter will undergo reuptake, which gets it out of the synapse. Well, the reuptake inhibitor is just like the name sounds. It's going to prevent the reuptake. So an example of this is cocaine, which is a reuptake inhibitor of dopamine. Dopamine normally gives us a very happy sensation, but at the end of the signal, it's going to get reuptaken. However, if you give cocaine, you're going to block that reuptake. This is going to keep the levels of dopamine in the synapse at very, very high levels. Thus, it will continue to give us that sensation and continue to give us that happiness or high, which is where the effects of cocaine come from. So, in conclusion, you have a wide variety of drugs that work on the brain by affecting neurotransmitters. You have agonists and reuptake inhibitors, which will basically both increase the effect of the neurotransmitter, whether by acting on the receptor directly or just increasing the level of the normal neurotransmitter. And on the other hand, you have antagonists, which are going to block the receptor and go against the effect of that neurotransmitter. So, thank you very much for watching, and I hope you found this video to be helpful.